Hello and welcome. I'm Bill Wake. We're working on parser-combinators. It's a functional language approach to parsing, and we're doing it in Swift. We did last week a lot of experiments and then started working on a production version right on the end of the day on Friday. The focus for today is going to be the or, so the vertical bar that says this or that or the other. And then I think we need to get errors under control too, error handling, I should say. All right, we'll take a quick review for me as much as you. Okay, so the core of this is there's the notion of a parser, and it's got an input type and a target type. And what you do is you're given a subset, a slice of an array of the inputs, so an array of characters or an array of tokens, and you're going to produce a parse result that supports the input and some sort of target type. All right. And the way the parse result works is it's got two cases. If you're successful, it returns the target value. And if you and it also returns the rest of the input, another slice. And if you fail, we just return an error or failure right now, saying I didn't find what I was looking for. We need to beef this up. We're going to have some more types in for the failure case. The thing I'm concerned about is we did a test with the OR operator, which is a type of parser. You give me this parser and that parser, and I'll run them both. Well, I'll run the first one, and if it fails, I'll run the second one and return the result. That's a starter one, but we haven't dealt with what happens when it fails. We've just barely, I don't even think we have a passing test yet. So this or else, we're creating it in the test for now, but it's got some sort of input type. You give two parsers that have the same target type, and it's going to hold the parsers and then do something. All right, and right now we just return failure. So yeah, our test is probably failing. Okay, so if you say, and remember it's a combinator because it takes parsers and builds bigger parsers. Okay, so the first parser, satisfy, that's a simple one that just, you give it a closure that represents a condition of some sort, and if it meets the condition, it returns success. Okay, so our condition, we're using an array of integers, and we're going to say, do you match the first item? Is the item 1? Okay, and the second one, does it equal 2? All right, and we're saying let's do or. The input type is int, and the target type. Let's see, did I do that right? No, the input type. Oh, the target is the same as the input target. Okay, so if this is a parser returning ints, and this is a parser returning ints, the result has to return ints. Okay, and give it the two parsers, and then try it against 1, 4, 5. So remember, our parse command takes an array or array slice of values, and then we expect to get a 1 because sat1 should be working. And, well, we expect it to be a failure because it always returns failure at this point. Up here. I've got to remember to run the test once as part of my startup before we roll camera and get it running from a little bit of a warm system, a little faster to start with. Okay, test started. Let's get a little room here. Okay, 1 failure. We expected a 1. We expected the result of the parse to be a 1 and the rest of the input to be 4, 5, but it failed. Okay, which we expect. So what we're going to do, well, I'm doing this very weird thing where I'm kind of half, it's I'm taking stuff that we did in our implementation, and it's not exactly a match for how we're working, but it's similar in structure. But let's make this thing pass. I mean, we could return success with hard-coded values, but I think we know we're running our parser, and so let result one equal parser one parse the input at just the input. Okay, so for our parser, parse takes an array of input and returns an input and target. Okay, so input, can I convert slice to slice of p1 dot input? Input. P1 dot input should be the same. Okay, I'm a little confused. Maybe I say and p input equals p1 dot input. Is that enough to get? Okay. Okay, well, that helped that. Okay, so now I have result one. If result one not failure, well, we're going to return okay. Let's do it the other way. If let result is target and array slice, target one, remaining one. If case. Okay, so if, oh, come on. Result one, what type are you? Parse result input p1 dot target. Okay. What's ambiguous? Oh, we have to say dot success. Good. Okay. Let's see. So if we successfully parsed it, well, no, that still sounds funny. If we successfully parsed it, we want to return it. But we did something wrong here if that's the case. But okay. But I think, can we get through the test? Let's see that first. Okay. All right. So I think I can do this, flip this the other way around. I mean, I could say guard case dot failure equals result 1. No, I still feel like there's a way to do this with an if. Let's see. If case dot failure equals result 1, do something. How's that look? Okay. Return failure. Well, that's the same as result 1, so I have two opposite things, so I can just return result 1. It's not a complete implementation. Okay, let's do it that way and check our tests. Okay, so this case works. Let's do the second case. Well, let's check that in. Okay, or else works if first parser works. Okay, and can match second item. And let's change this to 2, and the result should be 2. Okay, and we'll run tests. Okay. So now I think this is more appropriate. If case let failure equal result 1, we got to do something else. Okay, if result 1 fails, then we're going to let result 2 equal p2.parse of input. Same input. And let's return result 2 here. I don't know. I feel like there's a way to flip this around to make it a little more sensible. Slice of input. I guess P1 input has to equal P1 to input. I'm not used to using these type qualifiers quite so heavily, so it shows. Okay, but that worked. Good. And now the third case, and this is where nobody matches, or else fails to match. And this is kind of check failure. Let's see, where's check success? Okay, we do have a check failure. And all right, if it doesn't work, we tell what we got. Okay. This should be check failure result. One, two, look for 1 or 2, and we find a 3. Then okay, I guess we don't get the result back. Okay. All right. This Well, I think okay, that can't run. Okay. I think this is going to pass because we've sort of already covered this case, right? The if result 2 is successful, then we returned that. If it failed, we returned the other. Um, Now I don't know why. Did I try? I thought I tried if case not equal. Dot failure not equal. Oh, it's not a conditional. It's an assignment. I'm trying to reverse the order so parser 1 returns first. Because it's a little inside out at this point, right? You do parser 1. If it fails, you do parser 2 and return result 2. Oh, and if that didn't happen, you return result 1. And I don't think I can say if result 1 not equal dot failure. Cannot apply to parse result input operands. Can I? Oh, we tried making this equatable, but we don't control the types enough to know, even though it should be able to on this case. So I guess we're just going to have some clunky code. I can do an if case. Well, let's try that. If case failure equals result 1. Does that work? Because I really want to match the type codes. I don't care about the contents. Well, that's better. Let's see how that works. Build field. Return. Oh, okay. We know this is failure at this point. All right. Else handles parser 2. I think that's enough. All right, let's do some refactoring. Okay. These names can definitely work better. Parser 1. Okay. And then this was just inspirational, not functional. Okay. Now, one thing, okay. A thing that bugs me is we keep saying int all over the place. The only concern I have is when we're going to mostly use an operator, it's going to look like this. Oops, this. And usually you would write things that way rather than calling the or else directly. If the operator can work, it can infer the input types and all that stuff, then it'll look pretty good. I don't know if that's the case or not. I'm worried about choosing the input types. I really would like to, because I want to do it with tokens or I want to do it with strings. or I want the flexibility to let one parser convert to another parser. So I could have a parser of characters convert to a parser of tokens, convert to a parser of expressions, or something like that. Okay. And I don't know if these tests are similar. Okay. Let's extract this. And we'll put it up here. New file. Oh, didn't ask me the name. Okay, there's class. And this can delete. Okay. And everything should be good. All right. Let's see. I have a to-do list is in the other file. To-do list or operator. Yes. Error reporting. Okay. Good. I think we're still on that. And I think is this the right one? This is our old playground. And I know we worked on the operators. Yeah. So again, this is more inspiration, but I want to support that OR bar operator. Okay, and let's put it like there. This is not going to compile. Okay, but I would like to test with that. Okay, func test or else operator. And I think let's take the same test as this, but we'll write it differently. Okay, I sure hope this is sat1 or sat2. Okay, and this should fail to compile. Can't find the operator. Okay, so infix operator, and I don't know if the precedence is right, but that's the syntax we want. Now this, P1 a parser. Too few parameters. Okay, yeah, we're going to have to... Excuse me. P1, P2, or else P1, P2. Okay. Or else needs 3 because it needs the input. But we know the input is the same as P1. Can I do it like that? Okay, my fear was I'd have to put types of P1 everywhere, and I don't think I have to. All right, run tests. Cool. Easier than I thought it would be. All right, so that's what our grammar is going to look much more like, assuming things go well. All right, now let's, I think we can call this one done for now. PC-22-06, July 20th. Whew. Yeah, till July is almost done. Okay, but error reporting. Okay, so I'm not sure what to do about error reporting here. So the thing is, like, when I think about, well, we did the basic interpreter, right? And basic, a statement is, it's like an if statement, and this isn't uncommon, or it could be a let statement, or a print statement, or one of 15,000 other things. Okay. And well, 15 other things. You've got all these choices. We will put them here. Let's do some work to make sure that works correctly. But if you try and parse the if statement and it fails, you get back failure, and then you try and parse the let statement, failure, print statement, failure, and so on down through the list, and you get to the end and it's like failure. And all you know is none of these statements parsed. But let's imagine it got, if parenthesis a plus b equals 3, then and it messed up. Okay. So it practically got well into the if statement. The let statement, it's not a let statement. It doesn't get anywhere. Same for the others. If we've just said the statement failed, then we get no information about how it failed or how far it got or anything like that. So I know our failure is not enough. It needs a message of some sort, I think, maybe, but it certainly needs to know, like, how far did it get in the statement so it can decide which one was the right thing. Okay. So we're going to do some work on that kind of thing. And then I think also we want to make sure that our operator works like we expect. I'll just put one more test in here. We want to make sure it's left to right. I think we kind of know that. Actually, we do know that, don't we? Because we didn't try and check the first one. Do we need to do it for the 3 case? Situation. I mean, I guess that's just, I don't know my operator stuff enough in Swift, but if it's addition precedence, let's research this slightly. So Swift has a number of predefined levels. Oh, this is a good question. Is there a list? Yeah, there's a page. Okay, that's what we want. Okay, so we got operators. Okay. Bitwise shift precedence, not associative. Okay, so our group is left associative. Addition. Okay. Yeah, so there's a series of these. Most of them are kind of not a fit for us. I guess you could work with logical conjunction group and disjunction. I mean, this is again and or XOR. Assignment is right associative. Okay, interesting. But they build in the associativity, so I'm not going to retest that. Good, but let's see. How can we? Maybe we just have to wait till we get our next operator. So, we would like the ampersand operator, the sequence operator, to have higher precedence than this. So it's going to correspond to multiplication precedence. I want to be able to say, I want to see a 1 and a 2, or else, it's an error. And if you got the 1 but not the 2, I kind of want to know that. Now the message, yeah, I don't know how we're going to get that through. Maybe we just have to add it in. But I think we're going to have both kinds of operators to show that this one got further than that one. right now the choice operator, it can only match one number, and yeah, so that's all it's got. Now you might wish for more choices on your base parser satisfy. Right now it just takes this condition. Well, okay, but let's go move on. All right. I think our next test then is the and then tests. Okay, so let's add those. I think something changed. I could swear it used to always prompt me for the file name. Oops, and then tests. Oh, and it's alphabetizing. Maybe that's just. Oh, tests. Okay. Test 0. Okay. Comport XC test. Can I be identifier here? Oh, it didn't pick up my package. Interesting. Maybe something's changed in that code that's not a good choice anymore. I don't know. Alrighty. Oh, what's the diff here? Okay, let's check this in. Forgive me for putting the new files in with it, but that's where we are. Okay. And then tests. Well, they're going to look a lot like or else tests. I'm going to switch up the input type, though, just to prove that really works. And I don't know. I think they're going to be so similar. We're going to need, it's the same situation. You got, you want two things in a row. You might have 0, you might have 1, you might have both. Okay, so let's see. And then tests. Matches both items. Okay, we'll make this a character. B, and then. So, maybe I don't need to specify that if it's already on here. We'll have to take that into consideration. And then is not in scope. Okay, parse. Let's A, B, C. Check success. Assumes ints. Okay. Let's go with numbers, and then we'll put a separate test in that just checks that characters work. Okay. Set int, set 1, set 2. This should be, and then parse 1, 2, 5. And this should be, ooh, It should be an array of 1, 2 is what we'd like. I know we worked way around this. Expected type int. Check success. Oh dear. Let's do this. Expected target T. Is that going to work? Cannot convert expected target to argument type int. Expected target. Nope, that's backwards. Input target. It's going to tell me T is not equatable, I think. Yeah. I don't know that I want to make my types must be equatable. That seems like a... well, let's see what happens. I think we went down that path a little ways. Okay, that's a little happier. Let's see this. Okay. That's something. All right, and let's do it up here like we did before. Class and then. I think public class and then. And it's going to look a lot like or else. At least this far. Okay, and then it's got an input type for sure. I'm going to hold off a minute here. Sorry. Well, let's finish the framework of it, but let's... because I have a simplification I want to try, so... okay, so and test is doing nothing. Let's go back to or else. Yeah, I wondered if I need this input type. P1's a parser. I think if I just say they're both equal and the target is P1.target. Is that going to work? Wake up. Okay, and this doesn't need that then. Type or else does not conform to parser. Add stubs. Oh. P1.input. Oh yeah, we don't need these here then. Good. Okay. Remove extra type info from or else. Okay. Now let's look at our playground. We had and then up here. Okay. He's two parsers. His target, boy. We definitely played around with this some more afterwards. And so I'm not sure how we want to do this. Cuz what we did, we said if the two targets are the same, then let's just return an array. In our case, we've got an array of ints. We're returning a pair of ints, so they're the same. So there's no conflict. Now there could be conflicts later, but we'll deal with them. Okay, so let's get the tests uncommented again. Well, at least this far. And I think we'll need that. Okay, so and then we're saying if you just have one type, well, let's say and then array. Okay, so that's a variant. Let's do and then array. And then up here we want to define and then array. And then array. It just has one type, which I think is just parser, right? P of parser. Produces a parser, and this is the thing that turns it into an array. We're saying the type alias is going to be the contents, the target type of the parser, and it'll result in an array. So the target type, and I don't think we need the constraint. Target is p dot target. Okay, and this is p. I don't know if I need the colon type there. Okay. And this is p dot input. Okay, so type in an array does not conform. Do you want to add stubs? Sure. Ugh. Type alias target, type alias input. Input is going to be p dot input. And target is p dot target, array of p dot target. Okay, and I think I have to get these all public because this is a library package, and yeah, boy. Okay, we're gonna have to check that one out too. Okay, p dot input. Well, that's now input target. I don't know if I need to. I'm wondering if I need this. Can I just say parser? No. Okay, input and target are set. We got parser 1 of type P, parser 2 of type P, and a parse function that returns input target. Okay, and then array specialized with too many parameters. Okay, we don't need this. We just need the type of the parser. Since they're both the same, missing return. Okay, let's just return .failure. Okay. Now, that also makes me wonder about or else again. Let's take another peek. I'm requiring P1 target equals P2 target, P1 input equals P2 input. That sounds like they're the same. I don't know. We may not need both these types here, but we'll come back. Okay, this test should fail. Okay, and then we're basically going to do like we did here. We're going to capture a result, and then instead of doing A or B, we're going to require the sequence. Okay, so here, okay, catcher parser 1 of input, and is there case let? I always mix up all this stuff. If let's do if let if it's a success, with an I gotta go back to our parser target and remaining. Okay. Okay. If that succeeds, then we need to do a second parse. If case let success, this can be target 1, remaining 1. Let me just pull that a little out. Okay. If the first parser succeeds, and then if the second parser succeeds, equals parser 2.parse. Well, input's the array slice. We got to do remaining 1. Okay, and I think what we decided was if we don't care what these values are, we can just return it. Return. Oh. Let's do it this way. Result 2 equals parser 2.parse remaining 1. If success equals result 2, then return result 2. Oh. Cannot convert return type of parse result P input P target to result type in. Then that's a mess. Okay. Oh, right. We need to return. Oh, we do need the pieces. Okay, that's good. target 2, remaining 2, case let. Okay, because our return type is the input's the same. Let's see, but the target is the array. Okay, so success takes an array of p.target, which is target 1, target 2, and then remaining 2. Okay, let's see. Do I believe this? Okay, we run the parser 1. I'm going to make it, well, let's see what works first. Run parser 1, find target 1 remaining. Run parser 2 starting at remaining 1. And if that succeeds, also return an array of the 2 results, with the remaining 2 being the rest of the input. Okay, and I think that should pass. Okay. Now, and then fails if only first item matches. Okay, so let's do this. 1, 4, 5. We're looking for 1. Gotta set parser like that. Okay, so, and then array. Satisfy this. Okay, so if you satisfy 1, we expect to satisfy 1, then 2, and yet we're parsing something that doesn't have a 2, so this is a check failure. Oh dear. Okay. Let's see what failure. These helpers aren't helping as much as I wanted. This one might be okay. Input and target. Okay. Can we make that fail if it matches the first and not the second? It falls down here. I guess we could return a success. Just kind of a temporary to make sure this test really would fail. Oh. Convert value of P to array. All this for a line we don't even want in there, right? Should fail. Okay. Make sure it fails the right reason. Expected failure got success. Okay. And I guess the next one is if nobody matches. If first item. test and then fails. Well, let's call this and then array fails. Okay, so we're saying 1 then 2, and it's got, well, we can even let it have a wrong answer there, but this test should pass. Okay. So, and then array handles 0, 1, or 2 matching values. Alrighty. And let's get this junk out. And let's add the operator. Well, it's going to look a lot like this. And then tests. Where's my... Oh, he's still up here. Okay. And fix operator multiplication precedence. And it looks like an ampersand. We just need P1 of parser. P1, P2. Oh, I lost my P1, P2. Parser P1, P2 of P1. All right, and I think I can afford to spell this out. All right, did I just do that without a test? I sure did. Okay. Well, let's put the test in anyway. And I think we want to take this as our case. Okay, operator 1, 2. This is sat1 and sat2. I'm always struck how deep it all goes, right? You have your logical operators that act kind of like your addition and multiplication and addition and multiplication and grammar rules that act like that and regular expressions that act like that. And, you know, that structure is very deep. Okay, so if you do 1 and then 2 and you match them, you should get the array results back. Okay. All right, and I guess I could swap them just to make sure nothing's goofy. Should fail. Okay, because 2 then 1 is not the same as 1 then 2. All right, and undo that, undo that. All right, and let's extract this to a file. Pay more attention, Swift file. Next. Oh, it doesn't ask me. I think that's a bug. It's certainly a, well, I don't know if you'd call it breaking change. It's breaking me. Okay, there's all that. Type alias cannot be declared public. This generic parameter uses internal type. Okay, so parser is also needs to be public. And no doubt these need to be public. And no doubt or else does not conform to that. Oh. Okay, I guess that's implicit. Okay. And or else. Well, let's add it. Do I put it here? No. But, and then, okay, run tests. Okay, so we extract. Nice. Okay. This is good. I guess I haven't kept my to-do up to date here, have I? I don't know if we want to do the other. There's a lot of variations of this one. Maybe we'll wait on those. I think I want to get the error stuff straightened out first. Okay, yeah. And I think we're probably done with this one for now. Wherever we got to. Losing control of my windows. P combo. Okay. So we have and or and a base parser. So in a way we're kind of at the minimal level and refreshing stuff, but I really do want to work through this error thing because I want the error messages to be somewhat useful, not just like you had a problem in this line. Okay, usually we take a break about now, so let's do that. Let's take 3 or 4 minutes and grab a drink, whatever. We'll come back and start working on this error handling stuff. All right, see you in a few. Hello, welcome back. I forgot it's a short session today because we started an hour late, so let's go ahead and deal with this error stuff. Okay, so let's do this. I think maybe we'll make a new file for it completely. Mac OS. I'll do this one for now. No, you just don't do it, do you? Okay. Oh. Error reporting tests. Okay, and then we'll just borrow some of this. import bcombo. Okay, so what I have in mind, well, in our parser, this failure, I think what we need to do is get the index. So we're in a slice. The slice has a start index that tells us where we are in the slice, and the further to further along we are, the bigger that index is going to be. And then I think we want a message. I'm not as sure there. So let's let's start making it up, I guess. So we got a function test. Let's say satisfy failure returns index. Okay, so I'll just borrow the sat parser here. All right, so we got a parser, and we're going to attempt to parse with it. Sat1.parse of 2. Okay, it's looking for a 1. It's got a 2. And we get a result. And we want to check that well, let's make boy. I don't want to break everything at this very moment. Let's do an if case. Oh no, let's do this. Okay, if that. All right, now if case let failure equals result, then something. And return. Otherwise, XCT fail. Didn't get expected failure. Okay, now what's the equality? Well, I want to say let's call it failure 2 for a moment. I think that'll break less stuff. Failure 2, I gotta have the index. It's got a let's call it location and a message equals result, and then we're going to check that location should be equal to should be equal to 0 because it's the starting point, and the message should be equal to something. Okay. As no member failure 2, we'll get there. Message should be I don't know. Did not find required value. That's kind of generic, but I think we're in a generic situation here. All right, and our parser will add failure to taking an int and a string. And let's see who breaks. There may be somebody that's looking for the whole type. Oh, well. Okay, this test will fail, by the way. Okay. Didn't get expected failure, got failure. So rather than failure 2, we got failure. Okay. That, what's going to break now? Well, let's just do the satisfy parser. I'm going to pull this stuff a little bit over this way. Okay. Satisfy int. All right. Return failure. Well, if it's empty, that we're not testing that. We're testing the case where it doesn't match its condition. So let's return failure 2, and it's going to be the start index of our input, original input, and the message is whatever we said it would be. Did not find expected value or something like that. Let's say expected. I mean, that's very generic, but we just know there's a condition. We don't have anything other thing to go by. Okay. This should pass. Okay. That's progress. Now let's handle this as empty case. That's a valid error. Satisfy failure. Satisfy for no input returns. I think this would be more accurate to say failure. Okay. Let's have this one say out of input did not find expected value. And this is that going to work? Are you going to infer that for me? Didn't get expected result, it got failure. Good. Okay, and then this is input.start index and the message. Oops. Thought I saw something going by. Failure 2. Oh, good point. Okay, our error reporting tests are working. Now everybody else who gets a failure is going like, what the heck's a failure 2? All right, but having these working is progress to my mind. So let's go make those other ones accept a failure 2. Okay, so satisfy that fails. Yes. Result. Let's see this thing. He's got an actual parse result. And then I think we're going to have to say what the expected failure is. Well, that's a little more work than I want, but let's do it. Let if case let failure 2 location 1 and message 1 equals actual. Okay. And if case let failure 2 of location 2 message 2 equals expected. Okay. And then we're going to assert location 1 come on should equal location 2 and message 1 message 2, and then otherwise expected but got actual. Okay, so we'll assume both are failure messages and check that their values are equal. If one or the other is not, then we'll do that message. All right, these tests will still fail. Okay, our reporting tests still pass, which is good. I'm surprised and then tests aren't complaining any, but okay. Oh, they have their own matcher. Okay. Satisfy fails to throw. What's result 2? Well, we expect to see a failure 2 with position 0 and did not find expected value or something like that. Build failed. Oh, all these places. Yes. Okay. I suppose I could look at the message. Did not find expected value. Good. We expect a failure 2 of or else, well, so location 0 did not find expected value. And then failure. Okay, good. I'm not sure what that's about. Check failure result. this. Okay. How do we build? Some of these tests should be getting better. Okay, this one's okay. What's the matter with this one? Expected failure 2 did not find expected value, but got failure 2. Okay. Those sure look the same to me. Did not find expected value. Oh, did I mess up my... Did not find expected value. What? All right, let's go back here again. Result, expected failure 2, 0. Did not find expected value, but got it. Okay, let's check failure again. Let's break in here and take a walk. Okay, let's see, actual. Failure 2 equals 0 equals 0, 1 equals did not find expected value. Okay, and expected. R1 equals failure 2, 0 equals 0, 1 equals did not find expected value. Okay, we'll step over. Location 1 is 0. Okay. Step over again. Location 1, location 2, message 1, message 2. Okay. Location 2. Oh. Ding dong. If this works, then we return. I don't want to break. I just want to run. Okay. That one worked. What's wrong with this one? Three. Ooh. That is correct. 3 is correct. Because we said the start index was here, which is the same as the end index. End index is always one past. Okay. Yeah, that one will correct. Well, we'll try. Out of in... Oh, yeah, that's right. Out of input. Did not find. Okay. I mean, it's kind of bad. I'm taking the result value. Now, this one is interesting. Okay, so this one, we just got a failure. And the failure came from our and then array. Here. Okay. Really, though, this is kind of where I want to pick up. This is when it gets interesting, because did you fail at the initial parse, or did you fail at the second parse? We would like to know the index of remaining 1. Well, should we use the input start index, the remaining 1, or remaining 2. And we got failures for those. This one's probably a similar case. Failure 2, and we got failure. So notice that and then is returning failure. The individual parsers were sat parsers, so they return a failure 2. So our goal is to get the proper failure 2 message here and return that, and then we're going to delete the the failure, the simple failure. Okay, so error reporting. Let's see, error reporting. So we made parse result include location and message. Okay, and then what we need to do next is make ampersand return dot failure 2 and then delete dot failure. Okay, because and rename failure 2 to failure. All right, so that's where we'll pick up. All right, so next time, tomorrow, I'm back on my normal schedule, so that'll be 10 a.m. Eastern Time to 12:30 p.m. or 3 to 5:30 p.m. UTC. So tomorrow and Friday, same thing. And then next week, I'm on vacation a little bit. I think I'm back Friday. I'll check, but I'll definitely be missing the first part of the week. All right, we made some progress. I think there's still some improvements we can do, but I think we're on track, on a good way. So we'll stop here and pick up next time. Thanks for joining me. Take care. Bye-bye.